Identifying fluorescent ballasts that contain PCB involves several methods. Firstly, check for no PCB label. Many ballasts manufactured after 1979 have a label that specifically states no PCB. Secondly, consult the manufacturer's website. Some ballast manufacturers provide information about PCB content on their websites. Thirdly, contact the manufacturer directly. You can contact the manufacturer of the ballast directly and inquire about PCB content. Ballasts manufactured after July 1, 1979 are not likely to contain PCB unless they have been in storage. Regarding the date of manufacture on fluorescent lamp ballasts, it is a requirement of the National Electrical Manufacturers Association (NEMA) that fluorescent lamp ballasts manufactured after July 1, 1979 have the date of manufacture clearly marked on the ballast. The date is typically printed on a metal label attached to the ballast. If you're uncertain about whether a ballast contains PCB, it is best to assume that it does and take appropriate precautions. PCB are hazardous materials and should be handled and disposed of properly by a qualified professional. The identification of fluorescent ballasts that may contain PCB is a crucial step for ensuring safety and environmental protection during removal and disposal processes. Polychlorinated biphenyls, or PCBs, were commonly used in ballasts as a dielectric fluid to help regulate voltage and current. However, due to their harmful effects on human health and the environment, their production was banned in the United States in 1979. Older ballasts, particularly those manufactured before this ban, are likely to contain PCB. When dealing with potentially hazardous materials such as PCB, it is always prudent to err on the side of caution. If there is any doubt about the PCB content of a ballast, it should be treated as if it does contain PCB and handled accordingly. This includes following all applicable regulations and guidelines for the safe handling, storage, and disposal of PCB-containing materials. These regulations are put in place to protect workers, the public, and the environment from the harmful effects of PCB. One of the primary ways to determine if a fluorescent ballast contains PCB is to look for a no PCB label. As mentioned earlier, many ballasts manufactured after 1979 are labeled with a statement indicating that they do not contain PCB. This label is usually prominently displayed on the ballast casing and is a reliable indicator that the ballast is free of PCB. However, it is important to note that the absence of a no PCB label does not necessarily mean that the ballast contains PCB. Some older ballasts may not have been labeled at all, even if they were manufactured after the ban on PCB. Therefore, it is crucial to consider other factors, such as the age of the ballast, when assessing the likelihood of PCB content. If a no PCB label is not present, the next step is to consult the manufacturer's website or contact the manufacturer directly. Many ballast manufacturers maintain records of the PCB content of their products and can provide information about specific ballast models. This information can be invaluable in determining whether a particular ballast contains PCB. When contacting the manufacturer, it is helpful to have the ballast model number and any other identifying information readily available. This will allow the manufacturer to quickly and accurately identify the ballast and provide the necessary information about its PCB content. In addition to checking for no PCB label and contacting the manufacturer, another important factor to consider is the age of the ballast. As a general rule, ballasts manufactured before 1979 are more likely to contain PCB than those manufactured after 1979. This is because PCB were widely used in ballasts before the ban. However, it is important to note that some ballasts manufactured after 1979 may still contain PCB if they were in storage or if manufacturers continued to use existing PCB stocks. Therefore, it is essential to exercise caution when handling ballasts of any age. Regarding the date of manufacture, the National Electrical Manufacturers Association (NEMA) requires that fluorescent lamp ballasts manufactured after July 1, 1979 have the date of manufacture clearly marked on the ballast. The date is typically printed on a metal label attached to the ballast. This requirement makes it easier to determine the age of a ballast and assess the likelihood of PCB content. By examining the date of manufacture, it can be quickly determined whether the ballast was produced before or after the ban on PCB. If the ballast was manufactured before July 1, 1979, it is more likely to contain PCB. However, even if the ballast was manufactured after this date, it is still important to exercise caution and consider other factors, such as the presence of a no PCB label and the manufacturer's information. When handling and disposing of fluorescent ballasts, it is crucial to follow all applicable regulations and guidelines for the safe handling, storage, and disposal of PCB-containing materials. These regulations are put in place to protect workers, the public, and the environment from the harmful effects of PCB. It is also important to note that PCB are regulated under the Toxic Substances Control Act (TSCA), which sets forth specific requirements for the handling and disposal of PCB-containing materials. These requirements include proper labeling, storage, and disposal methods. Failure to comply with these regulations can result in significant penalties. When handling fluorescent ballasts, workers should wear appropriate personal protective equipment (PPE), such as gloves and eye protection, to prevent exposure to PCB. Ballast should be stored in a secure location to prevent accidental breakage or leakage. When disposing of ballasts, they should be transported to a qualified disposal facility that is authorized to handle PCB-containing materials. It is important to keep accurate records of the handling and disposal of ballasts, including the date of disposal, the quantity of ballasts disposed of, and the name and address of the disposal facility. These records are essential for demonstrating compliance with applicable regulations. In summary, identifying fluorescent ballasts that may contain PCB is a crucial step for ensuring safety and environmental protection during removal and disposal processes. By looking for no PCB label, contacting the manufacturer, considering the age of the ballast, and following all applicable regulations and guidelines, it is possible to safely handle and dispose of PCB-containing ballasts. It is also important to remember that if there is any doubt about the PCB content of a ballast, it should be treated as if it does contain PCB and handled accordingly. This includes following all applicable regulations and guidelines for the safe handling, storage, and disposal of PCB-containing materials. These regulations are put in place to protect workers, the public, and the environment from the harmful effects of PCB. PCB-containing ballast should be disposed of at a properly licensed hazardous waste disposal facility. These facilities have the specialized equipment and expertise to safely handle and dispose of PCB. Do not attempt to dispose of PCB-containing ballast in the regular trash or recycling stream. Doing so is illegal and can pose a serious risk to human health and the environment. The EPA provides guidance on the proper management of PCB, including disposal requirements. Consulting these resources can help ensure compliance with all applicable regulations. Also, it is vital to train workers in the proper procedures for handling and disposing of PCB-containing ballasts. This training should cover topics such as the identification of PCB-containing ballasts, the use of personal protective equipment, and the proper disposal methods. Regular training can help prevent accidents and ensure that workers are aware of the potential hazards associated with PCB. Consider implementing a PCB management plan to outline the procedures for handling and disposing of PCB-containing ballasts. This plan should include steps for identifying, storing, and disposing of ballasts, as well as procedures for responding to spills or other incidents. A well-written PCB management plan can help ensure compliance with regulations and protect human health and the environment. Proper disposal can involve incineration at high temperatures or chemical treatment to destroy the PCB. These methods are designed to prevent the release of PCB into the environment. Always use a reputable and licensed hazardous waste disposal facility to ensure that PCB-containing ballasts are disposed of properly. They will use specialized equipment and techniques to handle and dispose of PCB safely and effectively. This will help to minimize the risk of environmental contamination and protect human health. The regulations surrounding PCB can be complex and may vary depending on the state and local jurisdiction. Staying up to date on the latest regulations is important to ensure compliance. Consulting with environmental experts or regulatory agencies can help navigate the complex regulatory landscape and ensure that all requirements are met. If a PCB spill occurs, it is important to take immediate action to contain and clean up the spill. This may involve using absorbent materials to soak up the spill, sealing off the area to prevent further contamination, and contacting the appropriate regulatory agencies. Prompt and effective spill response can help minimize the environmental impact and protect human health. Replacing old ballasts with newer, more energy-efficient models can help reduce energy consumption and lower utility bills. Newer ballasts are also less likely to contain PCB, making them a safer and more environmentally friendly option. Consider upgrading to LED lighting, which is even more energy efficient than fluorescent lighting and does not contain PCB. LED lighting can significantly reduce energy consumption and lower utility bills, while also improving the quality of light. Proper disposal of PCB-containing ballasts is essential for protecting the environment and human health.